let's just do this here. 7, 3, 5. Place value means this. You know these 3 digits, right? 735. How much is 7? Well, if you hold up your fingers, this is 7. How much is 3? That's 3. How much is 5? That's 5. But with numbers, when we look at numbers, the place where you find the number makes its value change, right? Because, yes, this 5, because it's in what place? It's in the ones place. What else do we call that place? We call it the units place. Ones or units place. Okay, yes, this 5, because it's in this place, only stands for, if you're counting your fingers, 5 fingers. But this 3 is not in the units place or the ones place, it's in the, mark with them here, kids. Yeah, it's in the tens place. So what does that 3 really stand for? What is 3 tens? 30. This 5 stands for just 5 units or 5 ones. The 3 stands for 3 tens or 30. And the 7, because it's in the hundreds place, doesn't stand for just 7, stands for 700. So if I asked you to hold up 735 fingers, it would be more than just flashing a 7 and then a 3 and a 5. It would be, how many people would it take to make 735 fingers? Did I do that math? How many people would it take to get 735 fingers? Oh, there's 3. Do we have a guess? What a wild guess. Zach, wrong?
300.
300 people would get you 3,000 fingers. Right? Everybody's got 10. If you have 300 of those 10, Janet?
70.
70 would give you 700. So we're getting closer. Clayton?
75.
75 would give you 750, which would be a couple extras, I guess. Luke? 73 would only give you 730. So you might want to go with 74, and maybe some of them have lost their fingers in tragic farming accidents. A lot of people lose fingers in different sort of ways there. So yeah, place value matters. By the way, sometimes the book will ask you to write it, to split it up into what the place values are. When they ask you to do that, that's what we call expanded form. We don't write things in expanded form because it would just take up way too much room if you're writing it out. So we kind of condense it all into this here. And your beloved book likes to relate this into money. Why? Because all of you pretty much, from the time you're, I don't know, a couple years old, everybody's always figured out that money is kind of a good thing. You gotta have it in order to get your candy bar, your ice cream, or whatever else is you kids buy. Huh? Food, well, most of your parents pick up your food for you. How many of you actually have to do this? How many of you do the shopping for the family? You say, hey, Ma, I gotta go to the store, pick us up some milk and bread and some stuff. No, most of your parents say, I'm gonna pick up whatever. So, and with money, money only works to a certain extent because in money we have a whole lot of different bills that don't really stand for place values. But what money do we have that is the ones and the tens and the hundreds? Well, it's the $1 bill. And we have $10 bills, right? And we have $100 bills. Those are the only ones we're going to talk about because $5 bills kind of mess us up with that because we don't have, our number system isn't in the 5 place value thing there, but it's in the 10, so that's good. Because they're going to ask you this. Well, look in your books on page 19. Will you open your books to page 19? I know this is not riveting stuff for 5th graders because I'm pretty sure you're pretty much up on all this. Like I said, 5th grade math starts pretty easy, slowly gets easier, and gradually gets really hard. It doesn't make any sense there. Everybody on page 19? do you see lesson practice letter C where it says, how much money is one $100 bill plus 10 $10 bills plus 15 $1 bills? How would you go about actually writing that on your paper? What is one $100 bill? Jacob? One $100 bill is just $100, right? But if you have 10 $10 bills, what would 10 $10 bills be? What is 10 $10 bills? John?
100,000.
Yeah, that'd be another $100. And then what is 15 $1 bills? Putting them all together, how much money would you have?
250.
$215. Have you ever seen a $1,000 bill?
Can I have?
Me neither. Have you actually seen one? What at?
My dad's shop, my dad's car shop.
He actually has a $1,000 bill? Somebody paid him in a $1,000 bill? Really? I have never, ever seen one. And then look, they'll do something like this. If you look at problem number 4, in 365, which digit shows the number of ones in 365? Chase?
5.
5. You can just write that down on your paper. You're talking on. What about problem number 6? Just looking at some of the big interesting ones there. If the greatest 2-digit odd number is 99, what's the greatest 2-digit even number? 2-digit even number. Joseph? Has to be 2 digits, biggest even number. Aaron?
98.
How about 98? Yeah. Why not 100? So that's 3 digits. What's the biggest 3-digit odd number? Luke? What's the biggest 4-digit even number? Oh. Lauren?
9,998.
9,998. Let's see if they try to trick you up here. Oh, I do want to talk about this one. Do look at page 21. Sometimes I'm really nice and give you answers to some of these problems there. Look at question number 29. If you have the number of tricycles and the number of wheels, I'll actually draw it. You don't have to write this on your paper. Just kind of look up here. What is this? Number of tricycles? 1, 2, 3, 4, 5. Do they have that? Is that what it is? Maybe I just went up to 4, but that's okay. 3, 6, 9, 12. 3, 6, 9, 12. We'll just go 15. Tricycles, wheels. You have to be careful with this. This is something 5th graders kind of get all goofed up with here. What rule describes how to find the number of tricycles for the number of wheels? Problem number 29. How do you find tricycles when you know wheels? Now most kids, for some reason when they go this, they always say, well, you multiply by 3. Okay, you've got it backwards. You answered the question that says, when you know the tricycles, how do you find the wheels? This doesn't ask you that. It says, when you know that this number, when you know the wheels are 12, what do you do to 12 to figure out how many tricycles you have? You have to be careful when they ask you those questions there. Autumn, it is? Divide by 3. And then they always throw in that last question, number 30, which says, if you have 27 wheels, down here, how many tricycles would that be? But you already know what you're supposed to do because you said it right there. What do you suppose that would be? Go back there and back. Boy, it's a good question. What do you think, Connor? If you know that you have 27 wheels, how many tricycles would it take to make 27 wheels? 27 divided by 3. 27 divided by 3. Yeah,
7.
27 divided by 3, you're close. What's that? 27 divided by 3. We can work on our multiplication table. Yeah, no. What do you think? No? No? 9. We have to do our multiplication and division. Perfect. All right. So your assignment then is lesson number 3 for tomorrow. I do have a quiz for you.